This is the same letters challenge. The goal here is if you're given two strings, which characters in those strings match? So if we were looking at the examples here, apple and banana, only A matches, right? The A's. None of the other characters. California and New York, we have O, R, and N. Capitals do not matter, right? And the final order doesn't really matter either. Anemone, it's definitely not an enemy. Just a little bit of a joke there. But in here we have a whole slew of letters that match up. So we really want this same letters function to return an array of matching letters. We can jump right in. Right now, again, it returns undefined because we aren't returning anything from this function. And functions with no return, they return undefined, okay? But we need to normalize the data. We always start by normalizing the data so that we have a level playing field, okay? So right here we have word one, and we want to change it to something so that we don't have uppercase letters. In this case, we can just go word one dot to lowercase, okay? And that will do it. If we wanted to, we could clear out the spaces. I'm not too concerned with that for this one, but that might be an interesting thing to do later. You'd really just have to add a replace on here to kill anything that wasn't a letter. In fact, let's go ahead and do that just for good measure. Replace, whoops. We are going to set up a regex. Inside of here, we're going to find any letter that is from A to Z. Actually, we're going to get any letter that is not A to Z, globally and case insensitive, and we're just going to replace it with an empty string, okay? So we've gone ahead and done that. A little bit of ad-libbing right in the video here. We're going to do the same with word two. So we can just grab that one, type in word two, and now we have a really solid place to get this started, okay? Once we've normalized the data, we can start to play around. Now, in previous videos, you'll notice that I follow kind of the same format. To me, strings and arrays are the same thing, right? It's an ordered set of something. In this case, it's an ordered set of characters. In an array, it would be an ordered set of anything, okay? So we can loop over this however we want, right? We didn't split it. Sometimes I do split it, but this time I didn't. But let's start with a for loop, because that's usually how I start these. I try to make it somewhat messy and build from there. So I is going to be equal to 0, semicolon, word one dot length. If you've watched this before, this is pretty standard fare. Is less than what? Oh, you know what? I did this backwards because I am reading it wrong, but I is less than word one dot length. That's a bit of a mouthful. And of course, incrementing just like this, doing the thing. Excellent. Let's go and grab that same thing and paste it inside. This time we're going to change it to J's, okay? And change this to word two. Again, I've done this a lot in the past, so this shouldn't really be any sort of a surprise, okay? And then inside of here, we're going to sort out what we're doing. So there's always going to be some sort of an if statement, and then we are going to push, okay? So found letters, let's go and do that. Dot push, push, I really can't type that word. And of course, something in here, okay? Since we need this, let's go and create that right away. So const found letters equals an empty array, and we can figure out the condition. Now in this case, we want to make sure that the word two letter is equal to the word one letter. We've seen this, I think, in the very previous video that I did here. So word two, what is it? Word two J, right? I don't know why I have these out of order right here, but word one I, just like this, equals word2j, okay? And if it is, then we want to push it in here. Now, we're going to push in word1i, okay? And then right down here, just like before, we return that really fast. Found letters. Brilliant. And if we run this, it should return a lot. That first array has 3 A's. Why? Because there are 3 A's in banana, right? We don't get anything special here, but we do get a lot of extra stuff in that last example. So we need, just like before, we need something different here, okay? Instead, what we need is we need to make sure that the letter is not in found letters yet, okay? So found letters dot includes, and of course that's word1i, right? Because that's what we're playing with, word1i for all of this. Now if we run this again, we get, should be a single A in here. It is empty. Why? Because this needs to be the other way around. So if it's not in found letters, then we do that. Let's clear this out one more time, run it, and we should get AORN-ANEMO, which is exactly the same as the commented code down here, okay? So we're in really good shape. And you'll notice that I start a lot of these challenges this way. I figure out how to make it an array, and I loop through it in a very complicated way, okay? It's not great. We can do better. If you wanted to pause the video and try to base it off of a previous video, you absolutely could. I'm going to keep going, and we'll see how we end up. So the next move would be to remove this, at least one of these loops, because looping twice, that doesn't feel very good to me, okay? We can do that by using includes, okay? So right here, we go word2, move it right to the front, word2 dot includes word1, wrap it up in parentheses, remove everything else, okay? And now because we aren't using J, it doesn't make sense to have that anymore. We can get rid of that, and one of these down here, tidy it all up, run it, and it should be exactly the same thing. AORN-ANEMO, okay? So we've done it. We're already cleaning it up. We're reducing it. At this point, I usually try to do something like get rid of this complex loop, because it does feel very complex to me, right? There's a lot going on. As an example, I've mentioned in previous videos how I routinely screw up the semicolon. I very often put commas instead, right? So it's not my favorite kind of loop. I'm going to copy that, comment it, bring it right down, and change it to let letter of word 1, okay? Which means that I get that letter out. And now down here, I can replace word 1, and word 1 with letter, okay? If I run this again, it should still work. And it does, because I haven't really changed anything. I've just reordered how this loop works. Instead of iterating through the integer, or through the index, sorry, not the, it is an integer, but through the index, I just peel off that letter directly and try to use it, which feels really clean to me, right? So every single time I'm trying to make things just a little bit better. At this point, I usually switch over to something like a higher order function, right? So again, commenting, pasting, right down here, instead of using this for loop, I might go, what? I might say word1.forEach, okay? So word1.forEach. This is going to give me that letter again. No surprises here. And no surprises here. I can just go and copy this, paste it right down here, get rid of the entire for loop, even this line right here. And if I clear this out and run it, it should just work. It doesn't because word1 is not a function. Here's where the changes happen, okay? So again, I didn't split this. There are two ways to split this. I could either write dot split like this, and I do need that empty string in there to say split on every single character, or depending on how I feel about it, I might just wrap this in a spread, which I've talked about before as well. Spreading a string immediately sends it out to an array of letters, okay? So now if I run this, that error should go away. Oh, it doesn't. Why doesn't it? It is very interesting stuff. Unexpected token. Okay, well let's try it the other way then. That's what happens when you try to freeform this thing. Get rid of this and back it up. Run it, and we get good. There it is. So usually you would be able to spread that. I must be missing something, or I'm racing along. That's what happens when you're just kind of freeballing it. Okay. So again, we have that for each. The for each is not that much different than this, but you might see both of these patterns. Okay. The benefits of the for is that if I had to exit early for whatever reason, if I had to return from the same letters function, this is the pattern that I'd want to use. And that's because I can, right? Inside of the for each, if I try to return here, it's only returning from this callback function. I'm not actually returning from the for each. It's still going to loop through all of those other things, which means that I'm still stuck inside of this function, okay? So you can go either way. In this case, either way works, but maybe, just maybe, we don't want to do this. Maybe we'll want to try it a different way. As an example, right here, we can comment this out. And I might try something like a map, or in this case, let's go with a reduce, okay? So I change this to reduce, just like this, and I move it up here, okay? Because reduce, along with map and filter, return a new array. Now I do need to do some things in here. As an example, I need to get the accumulator. I'll leave letter where it is. You can actually name these whatever you want. Some people will name this CUR for current, okay? And then down here, I need that initial accumulator, which is going to be an empty array, okay? And from here, if word2 includes letter, okay, we can get rid of this, just like that. So if word2 includes that letter, which is right here, then we want to do something, okay? And what do we want to do? We want to push that, not push it, but we want to return, okay? We want to return the accumulator with that letter. Now, I don't think this is going to work quite right yet. Let's give it a try just to be seen. Sorry, I should also always return, always, okay? So we were in a conditional here. I should also always return the accumulator, just like this. Now, if I run it, I should get a bit of a hot mess. Oh yeah, look at it, right? So we're doing some stuff here, making it pretty messy, okay? So there are a few things that we need to do here. First, we need to get rid of the duplicates. We do have some of those. Apparently not for that first one. That's very interesting. And we need to flatten this. The reason that it didn't flatten is because of this, so we can start there, clear it out, run it, and I should get just like that. I do have some duplicates down here. Very interesting that. We can figure that out by testing this, okay? So right here, we can check that the accumulator dot includes letter, okay? In fact, we want to make sure that it doesn't include letter. So if I do that, run it, it should just work. Please say yes. Includes, plural, making spelling mistakes. And there we are. We're back to normal, okay? I really like reduce It is so powerful, especially when you get into places where there's a lot of stuff going on. You might have a map followed by a filter, followed by a map. And I've had people in the past tell me just to use a loop, one of these ones, right? One of these fours to do it and gather it all up. But it can also be done with reduce, which means that all of your logic is in here. It's kind of socked away in a very efficient way. Okay, so learning to use reduce feels like a superpower to me, but we can do better. Okay. In fact, this is where I turn it all on its head. So let's go and look at some different ways to do this. I mean, if you get here, that's pretty cool. But some different ways to use this would be to use a filter. Okay. So for filter, we need to change our word a little bit. Okay. And the way that we do that is we need to set this. So we go and grab this right here, all of it, just because I can. Cut that out. We don't need to split anymore. And we're going to make a new array that is new set with all of that information. Okay. So it still has word 1 to lowercase. We're still getting rid of this information. We don't really need to do that down here with word 2 just yet. But at this point, we can do some stuff. Actually, I do need to split this before I forget, just like this, on those characters, okay? And here we filter. So bring my notes up because I'm getting distracted by the reduce. We have found letters. We don't need found letters anymore. We can return this directly. So all of this goes away, just like this. Looking a little bit cleaner. Found letters doesn't exist, so we go and do that. Right here, we're going to go new set again. And this time, we're going to do that filter. So word 1 dot filter, okay? And so we're only filtering on unique letters because that's what we have here, okay? And we get that letter, just like we did before, and ship it out the door. If word 2 includes, like this, letter, then we return it, okay? We run this again, and we get our array. Looking at this right now, I'm pretty sure that this isn't needed. Let's just try it really fast. Again, winging it a little bit. Yeah, so I was wrong there. You didn't need the split, but interesting times. We have 2 sets in here. So if we're going to use sets, we may as well use sets all the way, okay? And again, turning it on its head, copy and pasting this. Something that will become available in all browsers. Currently not available in Firefox, currently not available in older versions of Node, but pretty soon, hopefully, we can go and use this. So let's back out some stuff here, okay? The first thing I want to do is get rid of this, okay? So I just want that set of word 1 and getting rid of all this. We don't need the spaces, obviously. And the same thing, I actually want that for all of this as well. Only I want it to be word 2, okay? And so what we have here is we've created 2 sets, which is really interesting because in newer JavaScript, we can do some operations on these. So if you've had experience with databases, right, and you do those unions or intersections and stuff like that, you can do that here, which is really, really interesting. So instead of all of this, we still want to spread it out because we want an array in the end, and we're operating on 2 different sets, okay? So we get word 1, which is a set, and we do an intersection, okay? So an intersection is going to return all the things that are the same. Imagine a Venn diagram, and the 2 circles on the Venn diagram are overlapping, right? Where they overlap, that's the intersection. That's what we're going to return. So we're intersecting on word 2, just like this. And if this works, it should, right? It's exactly the same. Now, not exactly the same. The order is out, okay? And the order is not guaranteed in sets. So this is a good example of how even though sets are unique lists, the order is not guaranteed. Very, very interesting stuff there. But look what we've done. We've used two different sets, and we've used the language to generate our list for us, which is just awesome. This would return a new set, which is why we have to spread it out into its own array. But there we are, okay? And of course, the last thing. So the last thing that I like to do is kick it into full gear and try something different, okay? So way down here, I'm going to change this. And the way that I'm going to change this is I'm going to change it to a generator. I've used generators in the past. This is all pretty standard stuff. And we need to flip this around just a little bit. So I'm going to go back to creating a unique array of letters. And down here, we can just get word2, get rid of this part. So that's all good. Okay, we just have a string. It's lowercase. We've removed the spaces and whatnot. And now we're going to do stuff. Because it's a generator, we use the yield keyword. And I've talked about that in the past. We don't really return. You can return from generators, but you try not to. Instead, you want to yield, which kind of pauses the execution of this function. Okay? It means that if I call this function again, it doesn't start from the beginning. It starts from wherever the yield is. Okay? For that, we need a for, okay? Because you cannot yield from a callback function. So we need that for. We're going to let letter of word1, just like this. And now if word2 dot includes, okay, we use some of this way up high. If word2 dot includes letter, then we yield, okay? If I can spell it right, just like that, yield the letter, okay? Now, it only returns that letter in the yield. It doesn't return the whole array, okay? So if we go down here, and instead of doing this, I'm just going to console log these away for a second, okay? Because we're going to need to change them. But if I go and get check letters, okay? Let's just call it check letters if I could type. And I'm going to get same letters for California and New York so that we have some variance in here, okay? Just like this. Now, that doesn't immediately return anything. Instead, what I need to do is tell it that I want that piece of the pie, okay? That I want that little section of whatever it's yielded at. And so what I can do here is I can console log check letters like this dot next. And that will run that bit of code and get me the first letter. So if I run this right now, I should get O. Can't find variable word2, did I? Oh, see, there it is. So word2, we clear this out, we run it, and we get O. Okay. It also says done false, and I've talked about this in the past where if done is false, then there's more to come. It's saying I'm not done yet. And so what we can do is I can copy and paste this just like this. I can paste a bunch of them. And now if I run this, clear it out, run it, you're going to see that we get O, R, N, and then the rest of these are all undefined and done is true. Okay, so I can go through and do this as many times as I want. There's no harm, no foul. This is not really an efficient way of doing this, so we don't generally do it this way. But you can, right? If you had a structured bit of code that needed to do the next thing, you absolutely could. But instead, let's go back here and change this. So right here, right here, right here, okay? And what I'm going to do is I'm going to add in a spread, okay? Because the generator it creates an iterator for us. So what we can do is we can get all of that by spreading. Spreading iterates through the whole thing. It's kind of like it's running its own loop. Okay. So down here, multiple curses again for the win. Just like this, we can clear it out. We did have to change the console log, but if this works, we should get AORN-ANEMO. Okay. So lots of stuff. Now, to recap, we started off, we had to find the matching letters. And we did exactly that with some looping. We reduced the duplication in those loops because doing multiple loops feels funky to me. That feels like a bad time. So trying to reduce it to a single loop for efficiency, for maintenance ease, right? We switched it out to a different sort of loop that was easier to read. Did some for each. Could have used some maps in here or something like that, but went directly to a reduce where we gathered it all up. And then we got a little bit tricky with some stuff with sets, especially this intersection. I can't wait for that to be in every single browser because that's going to be awesome, right? And there are others. There is union. There is some other kinds of sets, okay? So going to be some cool stuff there. For now, it doesn't work in Firefox, doesn't work in older versions of Node, less than Node 22, I believe, okay? So fair warning, but it's coming. And then we finished with a generator, okay? And I think generators are very powerful. I wish I had the opportunity to use them more. I don't. So I play with them as much as I can in these videos. But here's the final thought to this whole thing, okay? I've been doing these for a while now. I've done a bunch of different challenges. They're all out there, right? You can go and find them and watch them. But I want to show you that I usually lean into a very specific toolbox. Again, I mentioned at the start that I treat strings like a special kind of array. So I will split it, I will pull it apart, I will do the work on it, and then I will put it back together or kick it out the door if that's what I have to do, okay? So I usually start with a couple loops because I like to make it messy at the start. And then I will reduce that down. But again, it's just strings, it's just arrays, lots of array stuff in here. The more we can get comfortable working with arrays, the more we can do with pretty much anything, okay? Going to the regular, the newer for loop, okay? Going to the for each, which I lean into all the time. Again, I usually put a map in here or maybe a filter depending on what I'm trying to do. And then I always try to do reduce because I love reduce. Again, any chance that I get to use it, you can do so much with it, okay? And then I usually try to put some spice on it by doing something a little bit different, right? Set, we have set so we can use it. That's a pretty good solution. Adding just a little bit more spice to that, and then the cherry on top. Okay, so this is my toolbox. If you're really thinking about it, this is the common things that I use from my toolbox. There are plenty of other things in that toolbox, but these are the tools that I use a lot. And hopefully in all these videos and probably future videos, if I keep doing these, you're going to see these tools come up again and again and again. Which leads to the question, what are your favorite tools in the language? What do you love doing? Did you do this a different way? Would you do it a different way? Hit me up in the comments and let me know. Otherwise, I will see you in the next one.